And welcome to part 2 of 5 on this lecture series. Here we're doing aggregate demand and monetary policy. So let's, get started, I guess. That's what we do. Okay, so here we're going to talk about how to derive a monetary policy curve. This is also known as the MP curve. If you want to be lazy and just call it the MP instead of monetary policy curve. Whichever one you want to do works for me. I don't really care. So this is a curve that exists in inflation and real interest rate space, and it describes all the points in which money markets are in equilibrium. Now, if you remember, the IS curve sits in output and real interest rate space and explains where all goods markets are in equilibrium. Now, a lot of older, more, as we'll say, antiquated models use a curve that describe the quantity of money in markets, that existed only in output and real interest rate space. But there's a problem here. Excuse me. Having little burps and hiccups at the same time, and I have a cat that keeps jumping on my lap, but none of that's your problem. So the problem here is central banks focus more on interest rates now than they do the actual amount of money floating around in the economy, right? They play with the amount of money floating in the economy, but it's because they're interested, no pun intended, on interest rates, right? They're trying to set interest rates. They're not necessarily directly concerned with the quantity of money. They're more directly concerned with interest rates. So because of that, well, we kind of have to use that information to derive this curve instead of looking at something that's explaining the quantity of money in and of itself, because the quantity of money, like I said, isn't as important. It's more the interest rate or the price of money, so to speak, right? So check this out. We currently have a curve that we derived that exists in output and real interest rate space, but we got to get something in output and inflation rate space, right? Well, the answer would be yes. So far, we didn't really have anything to do that because we didn't have any prices in the model that we've seen so far, right? All the stuff you've seen has been like output, real interest rates, consumption, investment, government spending, crap like that, right? But nothing with either prices or inflation. But remember how the central bank works in our little model here. They monitor output and inflation, and they use monetary policy to tailor the nominal interest rate because they can't set the real interest rate. They can only set the nominal interest rate, and they can really only set one nominal interest rate. But if they set that nominal interest rate, it's kind of like that movie Inception, if you've seen that, right? Remember, it's like, okay, we're going to set this little idea in this dude's head, and it's going to blow out in this huge set of actions. Same kind of idea here. They set one particular nominal interest rate, sort of like the baseline, sort of like price floor, so to speak, on interest rates, right? If they set that, everything else follows. So if they can set that interest rate, it's going to lead to changes in the price level via fluctuations in the interest rate. Therefore, if they're setting the nominal interest rate and it's leading to some change in the price level, theoretically it should be affecting the real interest rate. And when the real interest rate gets affected, output gets affected. It says output there, but it's supposed to be output. It was a typo on my end. Oops. So if we want to get a function that exists in output and inflation rate space, maybe like combining a monetary policy equation with the IS curve will do it, because if the monetary policy equation, right, is focused on some kind of an interest rate and inflation, and we have an IS curve that's output and a real interest rate, and if we know by the Fisher equation there's some kind of a relationship between the inflation rate and the nominal interest rate, which gives us the real interest rate, we take this and then we look at the monetary policy equation, their function that they have, right, which is to try to essentially control interest rates to have some effect on inflation to be able to try to monitor output, right? So our monetary policy curve, therefore, is going to be something, well, kind of like that, because the bank can set the nominal interest rate, this capital R. They can set that. They can't set lowercase r, which is the real interest rate. Now, they can set the nominal rate in hopes of affecting inflation, which then controls the real rate, but that takes some assumptions there. One of the assumptions we're going to make is what's known as adaptive expectations. We're going to get a little bit more into this later in the course, but essentially adaptive expectations means you update your information set based on things that have already happened, things you've observed. So the more things you see, the more things you observe throughout your life, the more you're going to update your information set. So if it's something that's been done in the past, you'll know what happens when it's done in the past. You kind of move forward from there. Now, there's another expectation structure called rational expectations, which is a little bit more rational, but we'll be getting into that a little bit later. So here's what you need to know right now. The Fed sets the nominal interest rate according to this right here, this equation 2. Capital R equals lowercase r, the little bar over it, plus alpha times pi t. Now this R, this lowercase r with the bar over it, is autonomous monetary policy. These are movements unrelated to inflation. And then with the Taylor principle that we discussed, right, that if there's some change in output or inflation, there will be a more than like one-to-one change, right? Remember that? Yeah, that's the Taylor principle. So if alpha is larger than 1, what that means is if there is any change via autonomous monetary policy, right, they're going to try to do something to offset the inflation rate by more than what that change was. So from equation 3 here, right, where alpha is assumed to be larger than 1, hence the Taylor principle is being satisfied, we can rewrite the real interest rate expressed as this. Now you're probably like, okay, so what the hell did you do? Did you just like switch a variable out or something? No, not really. Take a look. Because now we have the real interest rate instead of the nominal interest rate on the left-hand side. Now the autonomous monetary policy is still the same thing, but I got this lambda guy instead of the alpha. So what the hell is that? Well, lambda is equal to alpha minus 1. Do a little bit of algebra if you want to see how we get that, but don't worry about it. Taylor principle here requires that this lambda is larger than 0, such that should inflation increase, right, the central bank responds by raising the nominal interest rate. Remember, the interest rate they can control. They raise that sufficiently as to increase the real interest rate. Now, we have a function for the real interest rate, which we can then substitute into the IS curve. And for right now, we're going to be dropping the t subscript, right? So we're just going to assume this is all kind of like a static model. So right now, the real interest rate equals this autonomous monetary policy variable, which is assumed to be exogenous, things that happen outside of monetary policy, right? They exist outside the model, plus this lambda times inflation. Now, I've got the IS curve here. This is what we got from the last lecture. Now, the nice thing, if we look at this, right, there is something that allows me to substitute in the monetary policy crap. Look at equation 6 and ask yourself really quickly, where can we plug in that monetary policy equation? Well, you can just go ahead and hit pause because I'm not going to wait that whole time. It takes a while. So where can we get this? Well, if we take a look at it, right, we got this R here. If we go back to equation 5, there's an R. R, R. So what I do is I take equation 5 and I plug that in for the R, which is the last variable in equation 6. I plug that in there. If I want to get this guy in terms of Y and some measure of prices, to be able to get a graph for aggregate demand, well, with R equals R bar plus lambda pi, plug that in for R. In equation 6, I combine these two equations, right? And now I've got something in terms of output and prices. Well, actually, what it's really in terms of is inflation, right? Because inflation is PT minus 1 over P1 new minus old over old equals the inflation rate. So the IS curve, I've color-coded it here because I'm going to be nice to you guys. Right? Everything in pink is, well, what's in pink. And then what's in blue there, right, that is what I'm going to plug in for the monetary policy equation, which is this right here. Right? So you just combine like colors. It doesn't get any easier than that. So you just plug that in there. Boom, there we go. All right, so equation 10, I have now combined equations 8 and 9. Now, what we have here is a failure to communicate, whatever. what we got here is, well, a bunch of crap, but it's y equals a bunch of this crap plus lambda times pi. Well, that's pretty interesting because now I've got y output is a function of a bunch of crap plus something times inflation or prices. So now I've got something in terms of output and inflation, aggregate demand, right? So from this guy right here, from equation 11, boom, we have an equation for aggregate demand. That's pretty effing cool. Now I need to get this in the form of inflation being a function of output, right? Because you remember, demand and supply graph stuff, right? Price is on the vertical axis, so we want to get this in terms of inflation. So I just solve it for pi. This is what I get, equation 12. It looks like a lot of crap, but don't worry too terribly much because, well, a lot of the stuff is just constant, right? Because it's two variables we're concerned with here are pi and y. Anything that's not pi or y is exogenous. It's constant in the model. So if you think like y equals mx plus b, right? Anything times x, well, yeah, that's going to be affecting the x. But that b, that's just a constant. So I can kind of regroup all this crap together. And I'm going to get something that's kind of like y equals mx plus b. Now, given, of course, lambda is greater than 0, Taylor principle satisfied. And when that happens, this tells us that 1, aggregate demand is downward sloping. 2, aggregate demand is flatter if this lambda increases. And aggregate demand shifts out if this A bar increases. And it shifts in whenever this R bar increases. So this is what we get, right? On the left side here, this R and pi space, this is explaining monetary policy stuff. Now, on the right-hand side, I've got R and Y space. So that is the real interest rate and output. That's where we get the IS curve. The interest rate set by the monetary policy curve, the graph on the left, right? The interest rate set by that determines the interest rate that we see in the IS curve. And from that, where we have this interest rate and output combination, one of which is determined, we then just kind of draw the graph down to an aggregate demand. So the Taylor principle says alpha is larger than 1, lambda is greater than 0. The central bank will raise the real interest rate whenever inflation increases. But they can only change the nominal interest rate, which changes inflation, thus changing the real interest rate, hopefully, fingers crossed. So why would the central bank ever want to increase the real interest rate, right? Now that's actually a pretty solid question to be asking the Federal Reserve right now because they don't seem to have any interest in doing so. So why would they ever increase the real interest rate? Well, a couple reasons. One, suppose the economy is overheating. People essentially want more stuff than what producers can make. Well, that's not good, right? That means inflation's going up, which implies bad. The opposite of good. And when this happens, the central bank wants to cut inflation back down to their target. Currently, it's an average of about 2% per year in the United States. We'll see if that holds in the future. It would be nice if it did. So they'll increase interest rates, and when they hike up interest rates, it's going to reduce inflation, right? Because remember, they're going to kind of move in directions here. So if we were to increase interest rates, it's going to cut the economy. It's going to slow the economy down a little bit, right? Output's going to fall, but when output falls, so does inflation. So when the nominal interest rate goes up, which is what the central bank can control, inflation's going to fall and the real interest rate is going to rise. Now, when that happens, when we get this combination of these changes in these variables here, remember, output's going to be inversely related to the real interest rate's movements. What we saw with the IS curve there, right? So a hike in the real interest rate is going to cut output. If we raise the real interest rate, output's going to fall. We're going to go into a recession. The economy slows down because demand is no longer exceeding supply. So if demand is no longer exceeding supply, right? Well, the nice thing about that is we're no longer like pushing up on the capacity utilization constraints that we're seeing in production. Therefore, we're not producing more than what we could like naturally produce in a steady state. So they're essentially bringing the economy back down to where it needs to be. So we want to graph aggregate demand. Now we've graphed the monetary policy curve in real interest rate and inflation space, and the LM curve exists in real interest rate output space. Remember, we're not getting that, right? We're not dealing with the LM curve. That's crap that we're not going to worry about. Now the IS curve, I probably meant to type out IS curve instead of LM curve, so sue me. That exists in real interest rate and output space, but we want to graph in output and inflation space, right? But I've got two different graphs that you kind of play around with what those axes are a little bit. You can actually get what you need. That's what we do, right? So we did it algebraically. Now we're going to do it graphically. That means we need to draw a graph underneath the IS graph and label the vertical axis with a pi for inflation and the horizontal axis with y for output. And this gives us our aggregate demand graph that we've been wanting to get for so damn long now, like 12 slides. We draw a dotted line from the real interest rate on the real interest rate and inflation graph over the IS curve, which is what you saw earlier, right? And then we draw it down from there to get the aggregate demand curve. This will give us output and inflation combinations that satisfy where money markets and goods markets clear, thus giving us aggregate demand. This is what we do. We start in this graph right here, right? This interest rate here will satisfy some point along this monetary policy curve. Keep drawing the dotted line over to the IS curve, and then down to this graph down here. Now, if you notice, right, this axis y and this axis y are the same thing. The vertical axes are different, but the horizontal axes are the same, so we can do this. This is allowed. Draw this dotted line down here, and we get our aggregate demand curve. Now, aggregate demand is drawn holding autonomous monetary policy fixed, which governs the position of the monetary policy curve. Aggregate demand is drawn holding this A bar fixed, which governs the position of the IS curve. An increase in this R bar will increase the real interest rate for some given inflation rate, and from the IS curve, this leads to a lower level of output. Thus, the aggregate demand curve would be shifting in if we were to be raising that real interest rate. So if that real interest rate goes up, right? So we're going from all the stuff you see in black here is the original set, and everything you see in pink is like the new set. What happens is, right, this monetary policy curve is going to shift up. We have a new real interest rate. We draw that over to the IS curve, right? Now this point here has a higher real interest rate and a lower level of output. So we draw this down over to the aggregate demand. See, there's this horizontal shift, this horizontal difference between where this new real interest rate crosses the IS curve and where the old one did, right? That is the exact amount that aggregate demand shifts inward. It shifts in by this horizontal difference between the old real interest rate and the new one. So we're going to keep the inflation rate the same. The inflation rate doesn't change here. The real interest rate does. Therefore, in order to have a change in the real interest rate with no change in inflation but a change in output, we have to have a horizontal shift that is exactly equal to the amount that the real interest rate went up. So if you need a minute to look over this and kind of see exactly what's going on, feel free to hit pause. I mean, yeah, I'm not exactly like watching over your shoulder while you do this, so do whatever helps you learn, I guess. But whatever it is that helps you learn how to do this, take your time. Feel free, please. So when aggregate demand shifts back, it shifts horizontally such that it lines up with that new dotted line, which stops at the same height, or that rate of inflation, that was achieved in the original plot. Now, the inflation rate stays fixed here because when we draw aggregate supply, that's what's going to be determining the change of the inflation rate, right? Where aggregate demand and aggregate supply intersect. And we'll get to how that works when we learn a little bit more about aggregate supply. I would suggest practicing this on your own with cutting the real interest rate instead of increasing the real interest rate and see what would happen there. Then really just practice this on your own, trying to recreate the graph that I just drew. If you can recreate the graph I drew, and you can practice this with a reduction in the real interest rate rather than an increase in the real interest rate, and you can hopefully get the results that which should seem intuitive if you're doing things in the opposite direction here, then you should probably be in pretty good shape for this lecture. So let's talk about a couple of things that will shift aggregate demand, right? An increase in this A bar will shift the IS curve to the right for some given inflation rate and a given real interest rate, meaning that output will increase, shifting the aggregate demand curve out. Right, so if we have an increase in that A bar, right, remember that's what's going on with the IS curve. Anything that's going to increase this A bar is going to shift IS out horizontally. The amount that it shifts out horizontally is the amount that aggregate demand shifts out horizontally. And again, we keep the inflation rate fixed. So just the horizontal amount IS shifts is the horizontal amount aggregate demand shifts. So just a couple other things. We've talked about situations where it's been assumed that this alpha is larger than 1 or lambda is greater than 0. That's not always the case. In this particular case, where alpha is larger than 1 or lambda is greater than 0 and the Taylor principle satisfied, an increase in the real interest rate leads to a backwards shift in the IS curve, but a drop in aggregate demand. That's a output. But if the Taylor principle isn't satisfied, right, if alpha is not larger than 1 or lambda is not larger than 0, well, we have a different situation. So suppose lambda is less than 0. Well, this is where things get really strange, because this means now that the monetary policy curve is downward sloping instead of upward sloping like what we saw. So in that graph all the way on the left, right, with real interest rate and inflation space, now the monetary policy curve is downward sloping because that lambda was just the slope of inflation, right? So if we have R equals mx or m lambda pi plus b, right? Well, lambda is that slope parameter. Slope parameter goes negative. The monetary policy curve is now downward sloping. Downward sloping, well, things get really strange because that means higher inflation leads to a lower real interest rate. And then a lower real interest rate stimulates output from the IS curve. That sounds weird to you. That's because it is super effing weird. And this actually leads to an upward sloping aggregate demand curve, which is like really, 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 really bad. So we'll get a little bit more into that when we talk about like unconventional monetary policy and all that fun stuff, liquidity traps and all that. But for now, just know that that is a special case that can occur, but when it does, it's really, really bad. So to wrap things up for this, we've learned how to derive the monetary policy curve and how to derive the aggregate demand curve. We've also learned what will shift the aggregate demand curve. And in the next video, we'll start learning about aggregate supply and how to derive that thing. So until then, peace out, and I will be recording another video that will be posted within the next day or so. Thanks for watching, and keep a lookout for the next video.